السلام عليكم. انا معاكم دكتور احمد عيد، رجعت لكم تاني. دلوقتي هنبدا الجزء التاني من الريفيجن بتاعتنا. زي ما قلت لك ان انت الريفيجن هنشرح فيها كل المنهج جزء جزء، هقول لك كل الحاجات المهمه اللي موجوده في المنهج. كل المطلوب منك ان انت تتفرج على الفيديو اول باول. طبعا المفروض ان انت تكون خلصت بارت 1 اللي هو الفيديو الاولاني. طب هي المراجعه هتكون كام فيديو؟ لا، ما اقدرش احدد دلوقتي، انا بسجل وبنزل لك على طول الفيديو. زي ما اتفقت معاك هنشرح كل حاجة. كل اللي مطلوب منك ان انت تخش تشترك في جروب التليجرام وتعمل سبسكرايب في القناة وتفعل الجرس بحيث ان اول ما الفيديو ينزل تشوفه على طول، وتتابع معايا كل نص ساعة تقريبا هينزل لك فيديو جديد. Let's start talking about second topic اللي هو elements, compounds and mixtures. Starting with elements. Elements are substances made up of one type of atoms like sodium, carbon, and cannot split into anything simpler by chemical means. Let's check this picture. This is considered as pure metal, oxygen gas, diamond, which is considered as form of carbon. When we talk about compound is a substance which consists of two or more elements chemically combined together in a fixed ratio. For example, water and carbon dioxide. Let's check the compound picture. It's like this. As you can see, two different elements attached together: water, silicon dioxide. Even sodium chloride is considered as compound because it consists of different elements. When we talk about mixture is consists of two or more elements or compounds which have not been chemically combined, no chemical bond, and can be separated by physical means, and that's we will talk about it in this topic. Example, salt and water. يلا خلينا بقى نشوف مع بعض the differences between mixtures and compounds. Compounds considered as pure substances, while mixtures impure substance. Compound is made up of two or more elements combined chemically together by chemical bond, while in case of mixture, it's made up of two or more substances mixed physically. For compound, its constituents are in fixed ratio, while in case of mixture, its constituents are in varying ratio. Compound like H2O, for example, 2 to 1. Mixture, varied ratio. A compound can have properties different from its constituents. It's considered as new substances formed. Water is formed from oxygen and hydrogen, both of them flammable, hydrogen flammable, oxygen required for any burning, while water distinguish fire. In mixture, no new substance is formed. The properties of a mixture are the same as properties of its constituent. You can separate water from salt, still water and still salt. The constituents of a compound can be separated only by chemical methods, while in case of mixture, the constituent of a mixture can be separated easily by physical methods. And we can check an image for mixture. It's like this. Mixture of elements like nitrogen and oxygen. Mixture of compounds like water and carbon dioxide, water vapor. This one is considered as mixture of element, the blue one, and compound like carbon dioxide and nitrogen. The blue one is considered as nitrogen. When we talk about melting and boiling point, we talk about this part before. Pure substance such as element and pure compounds melt and boil at fixed temperature. For example, melting of water is 0, boiling point of water is 100 degrees Celsius. However, mixtures usually melt or boil over a range of temperatures. The presence of impurities lower the melting point of a substance and raise the boiling point. This means, for example, dissolving 10 grams of common salt, table salt, sodium chloride, in 1 liter of water lowers the melting point to about minus 0.6 degrees Celsius and raises the boiling point to about 100.2 degrees Celsius. The melting point can be useful in determining whether or not substance pure. When we talk about solutions is homogeneous mixture of two or more substances like sugar in water. For example, solute is the solid that dissolves, while solvent is the liquid in which it dissolves. Take care that saturated solution cannot dissolve any more solute, and we talked about this before. Let's start talking about separation of mixtures. First process is to separate insoluble solid from liquid. As you know, if a substance does not dissolve in a solvent, for example, we say that is insoluble. It's like sand in water. Sand does not dissolve in water, so it's considered as insoluble substance. The process is called filtration. Is a method for separating an insoluble solid from liquid. When mixture, for example, sand and water, is filtered, look at this picture. In this picture, sand remain in the filter paper named as residue. Solid remain in the filter paper and called residue, and liquid water go through it and it called filtrate. That's what we're talking about, which is filtration process. So in filtration process, it's considered as a method for separating an insoluble solid from a liquid. When a mixture of sand and water is filtered, the sand stays behind in the filter paper, it becomes residue, and the water passes through the filter paper, it becomes filtrate. Second way to separate a solid means dissolve. Solid from liquid solution. Solution is considered as solute dissolved in a solvent, solid dissolved in a solvent liquid. It depends on solubility properties or a difference in boiling point or even volatility. Separating a solid from solution in a liquid can be carried out by crystallization. When we talk about crystallization, the solution is evaporated to the crystallization point, which is considered as the point at which crystals of solute will form on cooling the solution to room temperature. Let's check this image. In this case, we just heat using tripod and gauze sodium chloride solution, and from time to time we take drop of sample on glass rod and check if it forms crystals on cooling or not. If it forms crystal on cooling, so we reach to crystallization point. That's what we will say. The solution is evaporated to the crystallization point, the point at which crystals of solute will form on cooling the solution to room temperature. Drops of solid are removed at intervals and allowed to cool. The formation of crystals is in one of these drops indicate that solution is at crystallization point. If you found this, allow solution to cool, crystals will form and can be filtered out, washed and dried. One of the common exam questions is making pure salt from rock salt. What is rock salt? Rock salt is like this. This is called rock salt, and we get salt from it. So we can use filtration and crystallization to obtain pure salt from rock salt. How? Rock salt consists of salt contaminated by various earthy or rocky impurities. These impurities are not soluble in water. It's like sand, for example. If you crush the rock salt, just crush it, and mix it with hot water, the salt dissolves, but the impurities do not. The impurities can be filtered off and remain on the filter paper. Impurities will remain on the filter paper, and the filtrate is considered as salt solution. The solid salt can be obtained from the solution by crystallization, and that we was talking about. This is considered as typical way that you can separate any mixture of two solids, one of them soluble in water and one of which is not. Common exam question. Let's talk about third method to separate a solvent from a solution. It's called simple distillation. When solution right here, for example, seawater boiled, the solvent changed to vapor. The solvent here will change to vapor. The vapor passes down a condenser where it converted back into liquid and corrected as distillate in a beaker. Take care that water in from here and water out from here, and we'll check now why. This stage, the stage occur is evaporation, then condensation. So we can say that distillation is divided into two processes, evaporation and condensation. What I told you about, water is fed into the condenser at the lower end. He may ask you to draw an arrow to show from where water in and water out. So water is always fed into the condenser at the lower end. That way it fills the condenser jacket better. Okay, and if the flow of water stops for any reason, the condenser jacket remains full of water. Two reasons for this way of filling. Every pure substance has its own particular melting point and boiling point. So as I told you before, one method to check purity of separated liquid is to measure its boiling point. For example, pure water boils at 100 degrees Celsius, and if it contains any dissolved solute, its boiling point will be higher than this. Let's start talking about how to separate two liquids. Almost the same method, but called fractional distillation. The difference is using of fractionating quorum. So when we talk about miscible liquids, what's meant by miscible liquids? Liquids that mix together completely, do not form layers. We are talking about two or more liquids. May be separated by fractional distillation, provided that their boiling points are different. The temperature is lower at the upper part of fractionating quorum. For example, boiling point of alcohol, ethanol, for example, 78, while boiling point of water is 100. So the temperature is lower in the upper part of fractionating quorum. The vapor reaching the top is only for the liquid which has lowest boiling point. So alcohol, for example, will boil and water stir down here. If water evaporated, water drops drip back into the flask, as you can see. The solution of ethanol and water heated with electrical heater because ethanol flammable. Then the vapors of ethanol go to condenser, and the temperature of thermometer during separation remain constant. Then we separate ethanol. After separating all ethanol, the temperature will be raised again. This means water will start to separate when the temperature reached 100. So, as I told you, the temperature is lower at the upper part of fractionating quorum. The vapor reaching on the top is only for the liquid which has lowest boiling point. The vapor of other liquids condense back in fractionating quorum and return back to boiling flask. When the first liquid of lowest boiling point, in this case we talk about alcohol, ethanol for this example, is distilled, the temperature recorded by the thermometer is increased to the boiling point of the second liquid, which is distilled into a separate container for sure. The last distillate is the liquid which has the highest boiling point. Let's take some notes. The mixture must be heated up to boiling point of one component of the mixture and less than boiling point of the rest of components. Let's say in this example to 78, not to 100, the lowest one. The thermometer is placed in vapor, passing into the condenser, not in liquid. Thermometer must be in vapor, not in liquid. The chemicals collected at different temperatures are called fractions. And important applications for fractional distillation include separation of liquid air into oxygen and nitrogen, separation of crude oil into petrol and paraffin, the separation of ethanol from aqueous ethanol in industry. Also in fractional distillation, take care that liquid with the lowest boiling point distills over first. Last method of separation, which is considered as chromatography, it's a method of separating a mixture of substances which differ in their solubility in certain solvent, and different strengths of the forces holding the dye to the paper. It can be used also to identify substances as well as to separate them. When we talk about chromatography, a spot of solution containing the mixture is applied on the pencil drawn baseline. We draw baseline with pencil. Look at this diagram. We draw a baseline in a pencil, and the solvent must be lower below the baseline drawn in a pencil because it's insoluble. Then spots will be separated, spot 1 or A, B, and C. This part is considered as solvent front, and we use grass rod and watch grass to just separate it to prevent evaporation of solvent. So a spot of solution containing the mixture is applied on a pencil drawn baseline. The paper is placed in a solvent. The level of solvent should be below the baseline in order to avoid mixing sample with solvent. Solvent rises up. The mixture begins to separate because of their different solubilities in the solvent. Wait until the solvent reaches near the end of the paper, which is considered as solvent front, as I show you now. Examine the number of spots. Let's take some notes. Baseline must be drawn in pencil because graphite is insoluble. Solvent must not reach the baseline so that the sample does not dissolve down into solvent. Chromatography technique can be applied to colorless substances like amino acids by spraying chromatogram with locating agent. A pure substance leaves one spot on a chromatogram, and if a substance is insoluble in the solvent, the spot does not move from the baseline. The ratio RF, which is called retention ratio or retardation factor, is defined as distance moved by solute divided by distance moved by solvent. In this picture, distance moved by whatever spot from the half of spot like this, or for the orange one, this distance, half of spot, divided by distance moved by solvent, starting from baseline to solvent front. We'll check this together now. Each solute or component has a characteristic RF value for a given solvent. This means that the value of RF can be used to identify a possible component. For example, just knowing RF and compare it with reference data booklet, for example. However, for this to be so, the chromatogram needs to be carried out carefully under controlled condition. You have to use the same solvent and same condition of temperature and so on. Using paper chromatography in analysis, you can use paper chromatography to identify the particular dyes in a mixture. If you think that your mixture M could contain dyes like G1, G2, G3, and G4, you can carry out experiment to determine this. He may ask you to do this in exam tomorrow. A pencil line is drawn right here, as you can see, on a large sheet of paper, and pencil marks are drawn along the line to show the original positions like this, G1, G2, G3, and G4, and M for the mixture that we use to show the original positions of various dyes placed on the line as figured below. If you check this one, mixture containing 3 dyes, as you can see, first dye is G4, second dye is G1, third dye is G3, and fourth dye G2 not present in the mixture. If you want to calculate RF value for G3, just dividing X over Y, X distance moved by spot or solute, divided by Y, which is distance moved by solvent from baseline or pencil drawn line to the solvent front. So paper chromatography can be used to analyze a mixture. Lines will not be present, lines like this will not be present on your paper, but they have been added here to help you measure the distance. One spot is your unknown mixture, M, and the other are single known dyes. We are talking about known dyes, D1, D2, and so on. The chromatogram is then allowed to develop as before. The mixture M has spots, dyes, D1, D3, and D4. They have the same colors as the spots in the mixture, but in exam it's not colored. So they have traveled the same distance on the paper. Check the distance, not the color. Although dye D2 is the same color as one of the spots in the mixture, it has traveled different distance, so must be different compound. Instead of just saying the spots move different distance, we can use RF value to describe how far the spots move. RF stands for retardation factor, as I told you before. Each time we do chromatography experiment, the solvent and therefore the spots will move different distances along the paper. This means you cannot just report distance moved by a particular spot, so we have to work out ratio instead. RF is distance moved by spot from pencil line divided by distance moved by the solvent front from pencil line. So as we just mentioned, RF is equal X divided by Y. RF for dye 3 is equal to this value. RF for other dyes, as you can see, the 3 spots right here. Blue spot 0.25 is like dye 4, 0.56 for orange spot is like D1, 0.81 is like D3, and D2 is not present. Because the spots, as we just mentioned, spots in mixture M have the same RF value as D1, D3, and D4, so we can conclude that the mixture contains these dyes. An RF value must be between 0 and 1. If in exam you get a number bigger than 1, you have probably divided the numbers the wrong way round, and RF has also no unit, same values. You have to be careful when using RF value, as they depend on the solvent used and on type of paper. There was no problem in the experiment described above because mixtures and individual dyes were all put on the same piece of paper. However, if the mixture was put on one piece of chromatography paper and the individual dyes on separate piece, you can still compare RF value as long as you use the same type of paper and the same solvent. And now we finish topic 2. Let's start talking about topic 3, atomic structure. It's not a large topic, we'll finish it about 10 minutes or 15. When we talk about atoms are considered as the smallest particles of an element that we cannot break down further by chemical means and show all the properties of that element. Atoms are mostly empty space, each consists of a nucleus and a cloud of particles called electrons that rotate around nucleus. When we talk about molecule, a molecule consists of 2 or more atoms chemically bonded together by covalent bond. The atoms that make up a molecule can be from the same element or even different elements. For example, hydrogen H2 is molecule consists of 2 hydrogen atoms chemically bonded together, while when we talk about water molecule, for example, it consists of 2 hydrogen atoms attached to 1 oxygen atom chemically bonded. As you can see in this picture, hydrogen H2 is 2 hydrogens, similar atoms, similar element, same element, while H2O, HOH, H2O molecule, the lines is considered as the chemical bond itself. When we talk about the structure of atom, atoms are made up of protons, neutrons, and electrons. You have to know that these particles are called subatomic particles because they are smaller than the atom itself. The nucleus is formed of 2 types of particles, protons, positively charged, and neutrons, neutrally charged. The relative masses and the charges of protons, neutrons, and electrons are shown in table below. he will ask you about this in the exam. Proton, relative mass 1 and relative charge plus 1. Neutron, relative mass 1 and relative charge 0. Electron, relative mass 1 over 1836 and relative charge negative 1. Look at this image. As you can see, protons and the neutrons inside the nucleus and the electrons surround the nucleus. Electrons are found at large distance compared to the size of the nucleus from the nucleus, large distance. In this case, they are found most of the time somewhere in the shaded pink area, found in this shaded area. When we talk about mass of an atom is concentrated in the nucleus. As you can see, mass of electron is neglected, very small and neglected. I'm sure you know that atomic number and mass number. Atomic number is considered as proton number. It's considered as the number of protons in an atom nucleus. Each of the 118 different elements has a different number of protons. Proton is considered as identity of an element. For example, if we said 11 proton, we're talking about sodium, 12 proton, magnesium, and so on. So atomic number is equal to number of protons, while the mass number or nucleon number is considered as the total number of protons and the neutrons in the nucleus of an atom. For example, mass number is equal to number of protons plus number of neutrons. Let's check this image. For cobalt, chemical symbol of an element, 27 is considered as atomic number, it's the number of protons. 59 is considered as mass number, summation of protons plus neutrons. So if you want to calculate the number of neutrons, it's 59 minus 27, it will be 32. When we talk about isotopes are atoms of the same element that have same atomic number but different mass number. You have to write this definition. Atoms of the same element that have same atomic number but different mass number. They have the same number of protons but different number of neutrons. For example, the chemical properties of isotopes identical. Why? This is considered as a question. Because they have the same number of valence electron. So, as I told you, isotopes have the same number of protons but different number of neutrons, also have similar chemical properties or identical chemical properties because they have the same number of valence electron, or we can say same number of electrons or same number of outer shell electrons. Isotopes of chlorine Cl35 is chlorine 1735 and chlorine 1737. Isotopes of hydrogen are hydrogen 11, deuterium, hydrogen 12, and tritium, hydrogen 13. Isotopes of carbon, carbon 12, carbon 612, and carbon 13 and carbon 14. When we talk about relative atomic mass, AR, chlorine appears to have mass number 35.5. If you calculate the number of neutrons for chlorine, you will get 35.5 minus 17. It's a fraction, 18.5. It is not possible to have a half neutron or even a half proton, all of them integral. So, must be something wrong with this. The number 35.5 is not actually the mass number for chlorine, but rather it's the relative atomic mass. Chlorine consists of two isotopes, as we just mentioned, chlorine 35 and chlorine 37, and a naturally occurring sample of chlorine contain mixture of this with different percentage. So when calculating relative atomic mass, or when we talk about relative atomic mass, it is considered as the average mass of an atom, considering the amount of each isotope present in naturally occurring sample of element. We can calculate the relative atomic mass of an element by just knowing how much of each isotope is present, which is considered as the isotope abundance, percentage abundance of an element, and working out the average mass of atom. Let's take some examples. Chlorine has two isotopes, chlorine 35, percentage abundance 75, and chlorine 37, percentage abundance 25%. What is the relative atomic mass of chlorine? The relative atomic mass of chlorine is 75 multiply 35 plus 25 multiply 37 over 100. It gives 35.5. So we can say that relative atomic mass of chlorine is 35.5 because of the relative abundance of its isotopes. Another example, a naturally occurring sample of element boron contains 20% of boron 10 and 80% of boron 11. Calculate the average atomic mass. The relative atomic mass of boron, 20 multiply 10 plus 80 multiply 11 divided 100, it gives 10.8. So we can say that relative atomic mass of boron 10.8. Let's take some notes. Atoms are electrically neutral, have no overall charge, because the number of protons, positive protons, is equal to number of negative electrons. For example, oxygen atom, atomic number is equal to 8, so it has 8 protons, 8 electrons. Electrons and the protons must be equal to give neutral atom. Ions. Ions are formed by gaining or losing electron. Ions have positive or even negative charge. For cations, it's formed by losing electrons and contain positive charge. Metals always form cations, protons more than electrons. For example, sodium lost 1 electron to give sodium ion, positive ion, cation. While anions formed by gaining electrons and contain negative charge. Non-metals form anion, protons less than electrons. Chlorine plus electron gives chloride. You can use the periodic table to find out the number of protons, neutrons, or electrons in the atom. The number of protons equal to atomic number, the number of electrons equal to number of protons, and the number of neutrons in the atom is equal to mass number minus atomic number. And now we finished topic 3. Let's start talking about periodic table. As you can see, this one is considered as a picture for periodic table. The vertical columns are called group. As you can see, group 1, look at this, group 1, group 2, group 3, group 4 until 7, and then group 0. When we talk about from left to right, like this direction, is considered as period. So period 1, period 2, period 3 until 7, the horizontal rows are called period. So, as you can see that elements are arranged in the periodic table in order of increasing atomic number, starting from 1 hydrogen, 2, 3, and so on, until 118, the last element. So elements are arranged in the periodic table in order of increasing atomic number. The vertical column in periodic table are called groups. The first 7 groups are numbered from 1 to 7, as you can see, group 1, group 2 until group 7. The final group numbered 0. The elements in the middle of periodic table, the orange elements like this, are called transition metals. Some of the groups have names. Let's say group 1 alkali metal, group 7 halogens, group 0 noble gases. When we talk about horizontal rows in the periodic table, they called periods. It is important that hydrogen and helium make up period 1. Look at period 1, only hydrogen and helium. Period 2 started from lithium until neon. Period 3 started from sodium until argon. So, as we mentioned, the horizontal rows in the periodic table are called periods. It's important to remember that hydrogen and helium make up period 1. The periodic table and the number of protons, whatever, neutrons, and electrons. Most of periodic tables have 2 numbers against each symbol. Atomic number will always be the smaller number. Take care, most of you confused in this. The smallest number is considered as atomic number. The smaller number with the element, it's not important to be written up or down, above or below. Just the smaller number, that's it. To not be confused. The other number will either be the mass number of the most common isotope of the element or even the relative atomic mass of the element. The periodic table will clarify this. He will tell you. You can use periodic table to work out. Periodic table is provided in exam. I'm sure you solved past papers and you check this. You can use periodic table to work out the number of protons, neutrons, and electrons there are in atoms. The number of protons is equal to atomic number. The number of electrons is equal to number of protons, as we just mentioned. The number of neutrons is equal to mass number minus atomic number. When we talk about arrangement of electrons in an atom, electrons move around the nucleus in a series of levels called energy levels or shells. Each energy level or shell can only hold a certain number of electrons. Lower energy levels always filled before higher ones. The lowest energy level is the closest one to the nucleus. Check this. The lowest energy level, the picture is not to a scale. The first level takes only room for 2 electrons, the closest one to the nucleus. As you go up, energy increase and distance from the nucleus also increase. The second energy level, only room for 8 electrons. And the third level, for the first 20 elements in our syllabus, the third level can hold a maximum number of 8 electrons. So as we just mentioned, electrons move around the nucleus in series of levels called energy levels or shells. Each energy level or shell can hold only a certain number of electrons. Lower energy levels are always filled before higher ones, as I told you. The lowest energy level is the closest one to the nucleus, as we just checked. The arrangement of electrons in an atom is called its electronic configuration. We will use chlorine as an example. The electron configuration of chlorine is 287 because it contains 17 electrons. This is considered as electron configuration of some element: lithium 2,1, beryllium 2,2, boron, carbon, nitrogen, oxygen, fluorine, and neon. First shell 2 and second shell increase by 1, 3, 4, 5, 6, 7, 8 electron in outermost shell. When we talk about potassium 19, 2881, calcium 20, 2882. So when we talk about electron configuration and the periodic table, electronic arrangement of the first 20 elements in the periodic table shown in this figure, and that's what is required from us. Hydrogen 1, helium 2, from lithium to neon, from sodium to argon, and then potassium and calcium. You can find 2 important facts. First one, the outermost shell electrons is considered as the same as group number. Group 2 contains 2 electrons in outermost shell. Group 3 contains 3 electrons in outermost shell. Also, the number of periods or shells is considered as the same as the number of shells filled with electron. Period 1, 1 shell of electron. Period 2, 2 shells. Period 3, 3 shells. Period 4, 4 shells, and so on. So we can say that elements in the same group in the periodic table have the same number of electrons in their outer shell. 1 in case of group 1, 2 in case of group 2, and so on. The number of electrons in the outer shell is the same as group number for groups from 1 to 7. Take care, group 0 started with helium 2 and then 8 in outermost shell. So if you know that barium is in group 2, you know that 2 electrons in its outer shell. The same for all other elements in group 2. Iodine in group 7, so it contains 7 electrons in its outer shell. Lead in group 4, so it has 4 electrons in its outer shell. The period number gives the number of occupied shells, or the highest occupied shell. Calcium 2882, so it's considered in period 4 because it has 4 shells occupied. The outer electron is in the 4th shell. Iodine in period 5 so has 5 occupied shells because it's in group 7, so 7 electron in the 5th shell. Groups in the periodic table contain elements with similar chemical properties. They react in the same way. Same group react in the same way. He may ask you about, let's say, group 1, or elements in group 1 react vigorously with water. You'll find this when we talk about alkali metals to form hydrogen and hydroxide with similar formula: lithium hydroxide LiOH, sodium hydroxide NaOH, potassium hydroxide KOH, and so on. All elements in group 7 react with hydrogen to form compounds with similar formulae: HF, hydrogen fluoride; HCl, hydrogen chloride; HBr, hydrogen bromide, and so on. All elements in group 2 form chlorides with the similar formulae: magnesium chloride, MgCl2, calcium chloride, CaCl2. The reactions of atoms depend on how many electrons there in their outer shell. These are electrons which normally get involved in bond formation. Elements in the same group have same number of electrons in their outer shell, therefore they react in similar ways. When we talk about noble gases, group 0 element known as noble gases because they are almost completely unreactive. Elements in group 0 have 8 electrons in their outer shell except helium, which has 2 electrons. The rate of reactivity of elements in group 0 associated with their electronic configuration. Noble gases are unreactive, and this may be a question tomorrow, because the outer shell is full, and so there is no tendency to lose, gain, or even share electrons in chemical reactions. When we talk about metals and non-metals in periodic table, the metals are on the left-hand side of the periodic table and non-metals are on the right-hand side of the periodic table. Metals in blue, non-metals in yellow. He may ask you to check any element, whatever, without writing its chemical symbol. He may write A instead of S, and he asks you, is it a metal or non-metal? He may ask you about its properties. So we have to differentiate between or compare between properties of metals and non-metals. Metals, solid, except mercury, liquid at room temperature. Non-metals, solids and gases, except bromine, which is considered as liquid at room temperature. Metals have high melting and boiling points, while non-metals have low melting and boiling points. Metals hard with high density, non-metals softer with low density, except diamond, which is very hard. All metals are good conductors of electricity and heat due to the presence of free electrons. Non-metals poor conductors of electricity, except graphite. They are insulator, but graphite conduct electricity. They are insulator due to absence of free electrons and have poor thermal conductivity, but except diamond. We'll talk about graphite and diamond when we reach covalent bonding. Malleable can be hammered into shapes, and ductile can be bored out into wires, while non-metals brittle when solid. When we talk about metals, shiny, sonorous. Sonorous means make ringing voice when struck, while in case of non-metal, dull and not sonorous. Metals form basic oxide. When react with acid, it forms salt and water, while non-metal generally form acidic oxide, which react with bases or even alkali to form salt and water. Take care of this part, he may ask you about it tomorrow. Form ionic compounds. It's positive ion in the compound for metals. Form both ionic and covalent bond. It's a negative ion in ionic compounds. Let's check this image. Copper, like other metal, conduct electricity. Mercury have most properties of metals: high density, shiny, conduct electricity. form positive ions. The only exception, it's considered as a liquid at room temperature. And this one is sulfur. Sulfur shiny, but it's not a metal. It's non-metal. كده نقدر نقول ان احنا خلصنا كمان lesson 4 predictable. ده كده هيكون الفيديو التاني. ان شاء الله في الفيديو التالت هيكون في اهم جزء او اكتر جزء انتوا بتتلخبطوا فيه، وهو جزء الكيميكال فورمولي، الايكويشنز والكالكيوليشنز، اللي هو جزء المول هيتشرح في فيديو لوحده، لان قد ايه هو جزء مهم وشابتر مهم. اتمنى تكون المراجعه دي قادره تفيدكم. شاركوني في التعليقات لو انتوا مستفيدين بالمراجعه وحابين نكمل ولا لا. شد حيلكم وما تنسونيش بدعوه حلوه بظهر الغيب. وان شاء الله هنتقابل في الفيديو اللي جاي، وهنتقابل كمان لأي حد فيكم هيكمل هياخد AS أو A2 الإكسل. إن شاء الله هنتقابل في الكورس الخاص بيهم. أشوفكم على خير. استنوا الفيديو اللي جاي. شاركوني بتعليقاتكم لو في عندكم أي مشكلة. سلام عليكم.